In the last video, we have seen problems on minus L to L. Now, let us continue with the problems. If f of x equals 2 minus x in the interval 0 to 4 and x minus 6 in the interval 4 to 8, express f of x as a Fourier series. Now, if we observe the given interval, this is similar to 0 to 2L. So, where 2L value is 8. So, 2L value is 8, which implies L is 4. So, the given interval is similar to 0 to 2L. So, the corresponding Fourier series expansion is f of x equals a0 by 2 plus summation n equals to 1 to infinity an cos n pi x by L plus summation n equals to 1 to infinity bn sin n pi x by L. Let us call it as equation 1, where L is 4 for this problem. Since we have two splitted function, the first function is taken as phi of x, which is equal to 2 minus x, and second function is psi of x, which is equals to x minus 6. Now, since the interval is between 0 to 2L, we should replace x by 2L minus x. 2L minus x means 2L value is 8. I will replace 8 minus x in the first function. So, if I replace 8 minus x in the first function, I will get 2 minus, in place of x I am substituting 8 minus x. It is x minus 6. So, x minus 6 is nothing but my second function psi of x. So, phi of 2L minus x is equal to plus psi of x. We can conclude that the function is an even function. Since the function is even, bn term is 0. We need to calculate a0 and an. a0 is given by the formula 2 by L integral between 0 to L f of x dx. So, 2 by L value is 4, integral between 0 to 4. My function f of x between the interval 0 to 4 is 2 minus x into dx. So, 2 by 4 is 1 by 2, integration of 2 is 2 into x minus integration of x is x square by 2 between the limit 0 to 4. Now, let us substitute the limit, which is equal to 1 by 2 into upper limit is 2 into 4 is 8 minus lower limit is 0 minus upper limit for this term is 4 square, that is 16 divided by 2 is 8. So, 8 minus 8 is 0. So, my a0 value is 0, which implies a0 by 2 is also 0. Now, let me calculate an. An is given by the formula 2 by L integral between 0 to L f of x cos n pi x by L into dx. So, 2 by L is 4, integral between 0 to 4, f of x between the interval 0 to 4 is 2 minus x. I will substitute it. 2 minus x into cos n pi x by 4 into dx. Here we have product of two terms. I should apply the Bernoulli's rule of integration. So, for that this is the first function and this is the second function. Here 2 1s are 2, 2 2s are 4. So, let me apply the Bernoulli's rule of integration. 1 by 2 into first function should be retained as it is, 2 minus x into integration of cos term. Integration of cos is sin n pi x by 4 divided by the constant term is n pi by 4 minus, again integration of this integrated function is minus cos of n pi x by 4 divided by n square pi square by 4 square into differentiation of 2 minus x is minus 1. This is between the limit 0 to 4. Now, let us substitute the limits. If I substitute the limit for sine term, sine n pi into 4, 4 gets cancelled, sine n pi value is 0. So, upper limit becomes 0. Similarly, sine 0 is also 0. So, this whole term becomes 0. Here, this term will be minus into minus into minus is minus 1 by 2 into this denominator of the denominator goes to the numerator. It is 4 by n square pi square into substitute the upper limit is 4. If I substitute 4 here, 4 gets cancelled, cos n pi minus lower limit is cos 0. There 2 1s are 2 2s are 4. So an is minus 2 by n square pi square into cos n pi value is minus 1 to the power n minus cos 0 is 1. This is the value of an. So after getting an, we should substitute in the Fourier series expansion, that is here 4 square is there, so it is 16 divided by n square pi square, 2 1s are 2 8s are 16. So cos n pi is minus 1 power n, cos 0 is 1. So an is minus 8 by n square pi square into minus 1 to the power n minus 1. I got a0 as 0 and an value. Let me substitute in the Fourier series expansion. F of x equals, since a0 is 0, 0 plus summation n equals to 1 to infinity. An is minus 8 by n square pi square into minus 1 to the power n minus 1 into cos n pi x by 4. This is the required Fourier series expansion for the given function. Again, if they ask you any deduction part in this problem, you should substitute x as 0. Here also you should calculate f of 0. Then you should simplify this by expanding the summation. You will get the deduction part. Let us see the next problem. Obtain the Fourier series for the function f of x equals x square in the interval 0 to 1 and minus of 2 minus x the whole square in the interval 1 to 2. Again, here we have a splitted function, and when we observe the interval, it is comparable with 0 to 2l. So 0 to 2l is compared with 0 to 2. Therefore, our 2l value is 2, l value becomes 1. Since we have two splitted function, phi of x is taken as x square and psi of x is taken as minus of 2 minus x the whole square. Here we should replace x by 2l minus x. Since the interval is between 0 to 2, we should replace x by 2l minus x, that is 2 minus x in the first function. So when I replace x by 2 minus x in the first function, I will get phi of 2 minus x equals 2 minus x the whole square, which is nothing but my function minus of psi of x. Here minus sign is there, here minus sign is not there. So which is nothing but minus of psi x. Therefore, function, the given function f of x is an odd function. Since the function is odd, a0 and an values are equal to 0. We need to calculate the value of bn. So bn is given by 2 by l integral between 0 to l f of x sin n pi x by l into dx. Now let me substitute the values. 2 by l is 1, integral between 0 to 1. F of x, my f of x is between the interval 0 to 1 is x square into sin n pi x by l is 1 into dx. Again I have product of two terms. Let me apply Bernoulli's rule of integration. So 2 into first function should be retained as it is, x square into integration of sin is minus cos n pi x divided by n pi minus integration of this integrated function is minus sin n pi x divided by n square pi square into differentiation of x square is 2x. Again we have a variable term here. So the next term will be integration of this integrated function. So integration of minus sign is plus cos n pi x divided by n cube pi cube into differentiation of 2x is 2 between the limit 0 to 1. Now let us substitute the limit. What happens if I substitute the limits for sine term? X, if I put x is equal to 1, I will get sin n pi value is 0 and lower limit sin 0 is 0. Now let me substitute the limits for cos term. So which is equal to 2 into, for this upper limit is I should substitute x as 1. So minus 1 square is 1 cos n pi divided by n pi. This is the upper limit value. Minus lower limit is 0 into any term is 0. Then for this term plus 2 by n cube pi cube into upper limit is cos n pi minus lower limit is cos 0. Now let me simplify the term. 2 into, we know that cos n pi is minus 1 to the power n divided by n pi plus 2 by n cube pi cube into cos n pi is again minus 1 to the power n minus cos 0 is 1. This is the value of Bn. Substitute the value of Bn in the Fourier series expansion with a0 and an values as 0. The next problem is obtain the Fourier series expansion for the function f of x equals e power minus x in the interval 0 less than x less than 2. So this is similar to our interval 0 to 2l, where 2l value is 2 and l value is 1 for this problem. So we'll write down the corresponding Fourier series expansion, that is f of x equals a0 by 2 plus summation n equals to 1 to infinity an cos n pi x by l plus summation n equals to 1 to infinity bn sin n pi x by l. Now, since the interval is between 0 to 2l, we should replace x by 2l minus x, that is 2 minus x. When we replace x by 2l minus x, it is e power minus of 2 minus x. I will get it as e power minus 2 into e to the power minus of minus x is e power x. Here the function is neither even nor odd. If the function is neither even nor odd, I told you the formulas here. If the function is neither even nor odd in case of 0 to 2l, we should use the Euler's formula like this. a0 is 1 by l integral between 0 to 2l f of x dx. an is 1 by l integral between 0 to 2l f of x cos n pi x by l into dx. bn is 1 by l integration between 0 to 2l f of x sin n pi x by l into dx. The same formulas we are using here, a0, an and bn. So let me substitute for a0. a0 is 1 by l, l is 1, integral between 0 to 2. Our function f of x is e to the power minus x into dx. So e to the power, integration of e power minus x is e to the power minus x divided by minus 1 between the limit 0 to 2. So minus 1 I will keep it as it is and I am substituting the limits. E power minus 2 minus lower limit is e power 0, which is equal to minus of e power minus 2 minus e power 0 is 1. Then by multiplying this minus sign, I will get it as 1 minus e power minus 2. This e power minus 2 can be written as 1 by e square. By taking LCM, I can write it as e square minus 1 by e square. But I want a0 by 2. a0 by 2 is e square minus 1 divided by 2 times e square. Similarly, an is given by the formula 1 by l integral between 0 to 2 f of x cos n pi x by l into dx. Integral between 0 to 2 f of x is e power minus x into cos n pi x into dx. Here we have product of exponential into cos function. I had given a formula whenever we have exponential into cos function. This is the formula, e power ax divided by a square plus b square into a cos bx plus b sin bx. This formula we should apply for the integration. Here in place of a I have minus 1 and in place of b I have n pi. By using the formula, I will substitute e power ax e power minus x divided by a square plus b square into a cos bx minus 1 cos bx minus n pi x plus b sin n pi sin bx n pi x. This is between the limit 0 to 2. This is the integration part. Now we should substitute the limits. Let us substitute the limits. An equals 1 by 1 plus n square pi square is a constant. Let me substitute the upper limit here, e power minus 2 into, for this term, minus cos of 2n pi plus n pi into sine of 2n pi. This is the upper limit. Minus lower limit is e power 0 into minus cos 0 plus n pi into sine 0. We know that sine 0 is 0 and sine 2n pi is also 0, which is equal to 1 by 1 plus n square pi square into e power minus 2 into minus, we know that cos 2n pi value is 1, minus e to the power 0 is 1 into minus cos 0 is 1, minus 1. Let us simplify the terms. 1 by 1 plus n square pi square into minus of minus is plus 1 minus e power minus 2, or this e power minus 2 can be written as 1 by 1 plus n square pi square into 1 minus 1 by e square. If we take LCM and if we simplify, we will get it as e square minus 1 divided by e square into 1 plus n square pi square. This is the value of an. So after finding an, to find out bn, we have a formula 1 by L integral between 0 to f of x sin n pi x by L into dx. That is, f of x is e power minus x into sin n pi x into dx. Again, we have exponential into sine function. We have a standard formula. Whenever we have exponential into sine function, we have a formula e power ax divided by a square plus b square into a sin bx minus b cos bx. I will substitute this formula. So, when I compare with the standard result, a value is minus 1 and b value is n pi. So, my bn value will be equal to e power ax divided by a square plus b square, 1 square plus n pi square into a sin bx minus 1 sin n pi x minus b cos bx, n pi cos n pi x between the limit 0 to 2. Now let us substitute the limit. 1 by 1 plus n square pi square into upper limit is e power minus 2 into minus sin 2n pi minus n pi into cos 2n pi. This is the upper limit for the whole term, minus lower limit is e power 0 into minus sin 0 minus n pi into cos 0. We know that sin 0 is 0 and sin 2n pi is 0, which is equal to 1 by 1 plus n square pi square into e power minus 2 into minus n pi. We know that cos 2n pi is 1 minus e power 0 is also 1 into minus n pi into cos 0 is 1. So, minus of minus will be plus. N pi is a common term. I will take out n pi as a common term, divided by 1 plus n square pi square into 1 minus, here 1 minus e power minus 2. Again 1 minus e power minus 2 can be written as 1 by e square. Bn will be equal to n pi by 1 plus n square pi square into 1 minus 1 by e square. By taking LCM as e square, my Bn value will be equals to n pi into e square minus 1 divided by e square into 1 plus n square pi square. This is the value of Bn. I got A0, An and Bn. We should substitute in the Fourier series expansion. Since the function is neither even nor odd, we should find out all the three coefficients. Even in case of 0 to 2l or 0 to 2 pi or minus pi to pi or minus L to L, if the function is neither even nor odd, we should calculate all the three coefficients. With this, problems on Fourier series is completed.